There's, I think, 5 parts total. Now, there is a little bit of graphing with this. So I said you might want to grab some graph paper. You could probably sketch these just on line paper. So really either one is fine. But let me put the directions up here real quick. First thing is to sketch a graph. So we can use our graphing calculators to help us with that. Sketch a graph and find the area. Remember, that's really what you're doing when you integrate. Find the area of the region bounded by the graphs of the equations. This is kind of like a sneak peek into what we're going to be doing more of, probably not until like chapter 6. But sketching graphs, graphing different equations, putting them all on the same coordinate plane, and looking at the region bounded by those graphs. This is something, again, that doesn't really go away. We'll come back and do a little bit more of this later on in Calculus 2. Calculus also, not Calculus 2. Calculus also. So, example 1, it's got 4 equations up there. Y equals 2x squared minus 3x plus 2. So that'll be a parabola. Then there's also y equals 0, x equals 0, and x equals 2. So on your paper, and I just kind of made mine blank right now. I'll start to fill it in a little bit. But on your paper, go ahead and sketch an XY coordinate plane. And what I usually do first is I like to graph the easier functions first. I know y equals 0 is a horizontal line. I know both of those in the back are vertical lines. So let me kind of see what that looks like first. So I'll just put a few places on each axis. And here we go. I'll probably just draw all of these in black because remember, we're trying to find the region bounded by all of them. So y equals 0, changed my mind, I'm going for blue. Y equals 0 is just a horizontal line at 0. That pretty well just turns into your x-axis. Okay, x equals 0. I'm doing the easy ones first, like I said. X equals 0 is a vertical line at 0. I'm not really sure how far I need to go here, so I'm just kind of doing it all the way for right now. And then x equals 2. I don't have lines up here, so I'll do my best, but that is just a vertical line at x equals 2. So the parabola is going to help me kind of fill in everything else in between. So, thanks. I'll graph this real quick on mine. You might have your calculator in front of you, but I'm just typing this parabola into my calculator to see what this looks like. Let me clear that out. It was 2x squared minus 3x plus 2. So you kind of have to imagine all of those other lines on this graph as well. Remember, we had y equals 0, x equals 0, and x equals 2. Most of the time, when you're integrating with respect to x, most of the time those vertical lines are going to become the lower bound and the upper bound. I'm only concerned about the part of the graph from x equals 0 to x equals 2. So just to be able to put this back on my coordinate plane, I'm going to copy down real quick a few points. I can see where that point is. That would be the point 0, 2, I'm just writing them down because I have a bad memory. If I trace to 1, then that's 1, so that's another nice point that I could put. And then if I trace to 2, that gives me back a 4. And that's probably all that I need for that parabola because, again, based on those vertical lines, I'm only concerned from 0 to 2. So let me put those points on here. We had 0, 2, 1, 1, and then 2 was all the way up here at 4. Again, this is just kind of like your right half mostly of that parabola. I'm going to go ahead and just kind of fill that in with a curve. So if you want to take it out further, you can. I mean, you don't really have to, but if you want to actually get the good picture of the parabola, you can put an arrow on that side if you want. But this right here is the region that we just bounded in with these functions. I'm not going to spend too much time coloring, but I want you to see what just happened. Once we graphed all 4 of those, we bounded in this region. So the whole point of this problem is to figure out the area of this region. Now, when we did this earlier, I think they may have actually, well, we actually graphed it ourselves, but they were always like nice rectangles or nice triangles, or we could cut it into a triangle and a rectangle. Not really the case right here because the parabola is a curve, and so I'm not going to be able to use a geometric formula to find the area. I'm going to have to integrate. So I'll go ahead and put A equals out front because this is technically the area. And again, when you integrate with respect to x, the lower bound is the smallest x value on that region. So the smallest x value is 0. Biggest x value that's been bounded in here is 2. Again, a lot of times, maybe not all the time, but a lot of times those vertical lines end up being your bounds. Now, the function that I'm going to integrate is just the function that they gave me. Again, we're finding the area between the function and the x-axis. So let's go ahead and start. I can keep the 2 out front, add 1 to my power, put my new power on bottom, keep the -3 out front, add 1 to my power, put my new power on bottom. That just becomes a plus 2x. Now, I'll go ahead and put the little bracket right here with the 0 and the 2. I can probably leave it like that and start to plug in all of my numbers. So which number do I plug in first? The 2. And again, show this work so I know that you're not just typing it into your calculator. I got to see how you integrated and also show a little bit of work with how you're plugging in the numbers. When I put in a 2 right here, 2 cubed is 8, so that turns into 8/3. That's just in the parentheses there. And then 2 squared is 4. 4 divided by 2 is 2. And then when I put in the 2 right there in the back, 2 times 2 is 4. Now I should subtract what I get when I plug in the 0, but take a look at what happens when you do that. This whole term is 0, that whole term is 0, and that whole term is 0. So you don't really even have to put that because subtracting 0 doesn't change anything. So basically, I'm going to go ahead and make that 16/3 minus 6 plus 4. I'm just going to type that into my calculator to see what I get. It's not going to be a real nice number, but we can round it. 16/3 minus 6 plus 4. It's like a 3.3 repeating. So if you just want to round it to 1 decimal place, that should be fine. Now we are talking about area, so we haven't done that in a little while. We should probably go ahead and say units squared. 3.3 units squared. Alrighty. Any questions about the first one? You graph it and then you integrate it based on what you see on the graph. All right, let's try, I think, just a couple more. Example 2, y equals the square root of x, y equals 0, and x equals 9. Okay, first thing I need to do is graph. Now, I probably should have left more room on the right-hand side. You might want to do that when you make your coordinate plane because we have to go all the way over to where x is 9. So let's see if I can do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Barely made it. That will be a vertical line. Y equals 0, that's just going to be a horizontal line. Let me put a little bit on both axes. So I'll draw these in blue again. X equals 9. Vertical, I got a little crazy with that one. Vertical line right through x equals 9. Then y equals 0. That, just like last time, is a horizontal line at y equals 0. Now the square root of x, I can graph that probably pretty quickly without my calculator. Put in a 0, you get back a 0. Put in a 1, square root of 1 is 1. Put in a 4, square root of 4, 1, 2, 3, 4, is 2. So that point is at 4, 2. And then I'll probably want to put in a 9 next. If you go all the way to 9, square root of 9 is 3. So that would be the area that we've bounded on example 2. Again, that last point on the vertical line is at 9, 3. Square root of 9 is 3. So when I set up my integral to find the area, what would be the lower bound? 0. We are going to like it when one of our bounds is 0 because 0 is really easy to plug in. Upper bound is 9. That's the biggest x value on there. And I'm integrating the square root of x. So I'm going to go ahead and turn that into x to the 1/2 power. Now add 1 to my power. So take a 1/2, add 2 halves. That ends up being x to the 3 halves, all over 3 halves. But the fraction on bottom, I want to flip that over, turn it into 2/3, x to the 3 halves power. And we're going from 0 to 9. So just like last time, plug in the 9 first. Now when I do this on my calculator, I'll just write it out real quick and then highlight it for you. I plug in the 9, I plug in the 0, and it's all going to be 0 in the back. But this is the part that I'm going to type into my calculator first. Remember, exponents come before multiplication. 9 to the 3 halves power is 27. So I just need to take 27 times 2 and then divide it by 3, and that actually works out nice. It should just be 18 units squared. That would be our area for number 2. And it makes sense that the answer to this problem is bigger. My graph didn't really look bigger because I didn't leave enough room on the right-hand side. But if I had spaced that one out like I did that one, 9 would be way over here, and the region that would be bounded in would be much bigger than this. So you can kind of use that to see if your answer makes sense, just based on how big the region is. All right, now last one. There is a little bit that we're gonna have to talk about on this one. So it should be another parabola right off the bat. It says y equals x squared minus 4x. And then y equals 0. Okie doke. Well, I know what y equals 0 looks like. That's the only really easy one to graph. So again, just a horizontal line at y equals 0. And then to see what's going on with the parabola, you can graph it on your calculator and then just recreate it on your graph. I need x squared minus 4x. I'm going to erase the dots from earlier. And remember, the only other graph on this problem is y equals 0. So if you imagine that line being right here where it belongs, the area that's bounded in is the part under the x-axis. So really, I'm going to put a point right there at the origin. I'm going to put a point over here at 1, 2, 3, 4, 0. And I guess if you want to draw the vertex there too, there's a point at 2, negative 4. So let me first just put this all back on my coordinate plane. I'm gonna label a little bit on each side. So 0, 0, 2, negative 4, and 4, 0. Those are the nice points on the parabola. So I may not color it all in this time, but you can see right here, that's the area bounded in. You can put the arrows on the parabola if you want, but this right here is what we're trying to find the area of. Now before I actually do this, does anybody remember what I told you about when you're taking the area of something under the x-axis? You get back a negative. Now we're going to have to kind of put that in terms of this problem, but I'm already expecting a negative answer because the region is below the x-axis. So I'll show you what to do about that here in just a second. Now the integral, smallest x value is 0. We got pretty lucky today. All of them had a lower bound of 0. Not sure that that will always happen. But then upper bound is 4. And the function that you integrate for these problems here, it's usually just that first one that they gave you that actually has something going on. In this case, it's the x squared minus 4x. So add 1 to my power, put my new power on bottom. Second part, I'll keep the negative 4 out front. Add 1 to my power, put my new power on bottom. I probably want to simplify that before I do anything else. So I'll make it x cubed over 3 minus 2x squared. The negative 4 divided by 2 gives me the negative 2. Now I want to take that from 0 to 4, but I got to plug in the 4 first. So 4 cubed over 3 minus 2 times 4 squared. I'm not even going to worry about plugging in the 0 because I can already see that when I do that, all of that turns into 0. So 4 cubed divided by 3 minus 2 times 16, basically. 4 squared is 16. That, if you round it off, gives you back a negative 10.7. Now, here's what we kind of have to think about in this problem. If we are finding the area of a region, just in general, the area of a region, should it really ever be negative? No. Now, I've got a little bit on the PowerPoint here about this, and I thought I would do that. I wrote right on top of it, but you might actually want to copy down something about this in your notes today. When you're finding the area, and I put quotes around that because if that's what it says in the directions, find the area of the region, then your answer should always be positive. Right now, I have negative 10.7. So because my answer should be positive, all I'm going to do is I'm going to take that answer and remove the negative sign. So actually our answer is 10.7 units squared. If you imagine this same region just above the x-axis, then it would be positive 10.7 instead of negative. Now, it is possible, and I think I put this up here too in case you want it. It is possible to get negatives if you are just asked to integrate. It says if you are just finding the value of a definite integral and there's no mention of the word area, then you can leave that as a negative. If they don't say anything about the area of some region, that's okay to be negative. But again, keyword, area. If it says area in the problem, then answer should really be positive. Okey-doke. Now, I will give you the assignment here. You should have plenty of homework time. So, it is C80 now, all the way up to 80. From page 328, we're doing 39 to 46.